And we are live. Hello, everyone. Welcome to I Build at 4 a.m. Series 2, Modularity Simply Put. Buckle up, because in this podcast, we are now going to talk with some very smart guys. I have here co-hosting with me Carsten Monk for the Cartesi Foundation, board director. Say hi, Carsten.
Hello, hello.
And we are hosting here our friend Luis, who is a project manager for Shutter Network. And we'll dive deep on how Shutter is contributing to security in Web3 through threshold encryption to prevent malicious attacks, protecting community from manipulation, and improving fairness in blockchain applications, right? So, hey, Luis, how are you?
Hey, very good. Thank you. Thanks for having me.
Yeah, I think it would be really nice if you could give like a very short summary, a few sentences on what is Shutter and who are you, of course.
Sounds good. Yeah. So Shutter. So I'm a product manager at Brainbot, which is the development house originally having incubated a Shutter network, which and Shutter is a threshold encryption (DKG), so distributed key generation mechanism. Essentially, it's a cryptographic protocol which is designed to sort of churn out keys, right? Churn out encryption and then decryption keys in a decentralized way using threshold encryption, and in a way that forces the decryption as well, which is also important. And so it serves commit and reveal use cases, so things that would make sense to have kind of encrypted and then committed to, and then decrypted and then executed, I would say, right? And one of these things are sort of the two main cases. We built this as a generalized kind of primitive, and people can build on top. But the two use cases we're most focused on ourselves as well is MEV and censorship protection, where this encryption mechanism serves as an encrypted mempool for transactions in general. Before they are sort of included in the transaction in the block. And there we work with the OP stack, and we work with a Gnosis chain. We're live on mainnet. So there again, it protects against MEV and real-time censorship because it's encrypted and people can't see what's in transactions. And then we also have this other use case, essentially, that we call it shielded voting, where the same encryption decryption mechanism encrypts the vote, the real-time voting results while the vote is going on, and there we are integrated into snapshot. So if you have a snapshot space, you can go to the admin settings and switch it on, essentially, and then
This is awesome, Luis. Thank you so much for that intro. I just want to do a call to action here real quick. And if you are interested in this episode, please follow us and follow Luis, of course, and throw your questions in, because Luis is going to be answering many complicated questions. If we have time at the end, we're going to bring the community questions for him, and even give prizes such as a swag kit for the best question. So I think we can move on to the questions right now. And first of all, before getting more deep into Shutter, I wanted to get to know a little bit about your experience better, right, Luis? And as a project manager, so not a developer, what's your experience dealing with teams that are highly technical, developers in Shutter Network? How do you align with them? How do you manage to communicate and even grasp the concepts that they bring to you, the discussions that are raised, and everything?
It's a very good question. Yeah, so I was sort of thrust into that, I would say. So originally, my background is in finance, and so and then via consulting, sort of, I got into the crypto space in 2016 full time. And originally, I was doing everything, I would say, sort of like between business and finance and admin and everything, I would say. And then only slowly did I sort of move closer into this sort of product management role, which, I would say, and the challenge you're describing is very correct. Yeah, I'm not a developer, so sometimes it's not easy, I would say, to understand all the problems deeply. But I would say we are tackling it definitely from two directions, I would say. One is kind of being in this space and being close to these topics. Over the years, I kind of got pretty familiar with some of these technical concepts, maybe not on the practical level of how to code myself, but more so on a architecture or kind of game theory and economics and cryptography perspective. So I think that's helping, and that's what you have to do, kind of, right? Even as a business person, so in crypto, I think it is a technical topic, so you have to kind of dive into it. And then on the other side, and more importantly, so I would say, is in our team at least, it is our hierarchies and the way we decide things and the way we work is very collaborative, I would say, so that and very kind of flat hierarchies and bottoms up driven. So it's not that sort of the project manager or the product manager defines things and then they're kind of executed, but it's more so an ongoing discussion, and our lead developers have a lot of say in what the direction is, also on the product and business side.
It's good, right? It all enhances and leans towards this ethos of the open source, of the project development industry, where everyone has a voice, where everyone participates.
Yep, exactly. Yeah.
Yeah. Anything in your background from finance, from administration, that you feel transpired, converted very well to what you do today, specifically? Something that really helped?
Yeah, funnily enough. So, I mean, I would say that some of the topics also during my studies, or I did my bachelor thesis at the high frequency trading professor, chair, and interestingly enough, kind of that maps these traditional finance problems of kind of front running in traditional finance, high frequency trading, payment for order flow, which is now just was banned by the EU. So in the EU earlier this year, some of these problems map one-to-one to the things we're seeing now in crypto, right? So payment for order flow is kind of what PBS is, right? Builders are paying, for example, RPCs, private RPCs for order flow, right? Front running exists as well, right? It's just handled differently, and kind of high frequency trading arbitrage also maps very well. So it's pretty interesting to see how this, the same things, also intense, right? This intense vision of intense-based trading is also something that I would say in the traditional finance, it's just what brokers are doing, right? You go to the broker and say, I want the best price, and the broker usually goes out and tries to find the best price, but you need to kind of trust them a little bit. And there are things like the MiFID in Europe, again, MiFID best execution, where you are obligating the broker to actually make sure that they can provide the best price. So that maps very well to kind of this intense based trading vision. Yeah. So and in general, I would say, like, definitely kind of traditional finance inspires you to work in crypto oftentimes, because you see how chaotic and how the fees, how many fees are kind of hidden somewhere and where you don't see them, right? Where there's lack of transparency, and you have these, in banks they have these, always, I think all banks have this, you have like always parallel IT systems that do exactly the same, but they're just legacy IT systems where they just have to be kept alive like a zombie kind of infrastructure, because there's one edge case where you still need the old system. So you have like 3 systems that map the same, let's say, derivatives or client database, whatever. And yeah, so that inspires you that easily, I think, inspires a lot of people to go to crypto, because hopefully crypto is the idea to have one big database, which has doesn't have this redundancy and doesn't have the hidden fees, and because it's all hopefully transparent.
Yeah. So of course, like one of the ways that you're trying to kind of solve this is with your shadow network, so-called, let's say, encrypted mempools. Like, what would you say is kind of like the difference between public mempools? And by the way, mempools, for, let's say, the audience here, is basically, let's say, the state of incoming transactions to a network. They kind of like can sort in and so on, kind of like put together into a block. So what problem do you kind of like try to aim to solve with your encrypted mempools?
That's a very good question. Yeah, and I would even say that there's three different types of mempools at least, right? So the traditional public mempool, which has some of those downsides, right? Because it's chaotic, because everything is just coming in, and people can then, with advanced knowledge, can then take some of the transactions and front run. And then so that's where some of these front running problems pop up. So then we have the quick fix was always like private mempools, right? Where you say, okay, let's just have one entity kind of be in charge of receiving transactions, and then you quick fix some of these issues with front running and censorship and some of these other problems or spamming. But then you have a private mempool, right? And you have private order flow, and you have kind of a centralizing force there, because then it's all concentrated towards that single RPC. So I think that the third category is the most interesting, where what we want to achieve is kind of a public encrypted mempool, where it is open to anyone and not centralized, but rather just your usual public mempool, but it is encrypted, and which hopefully can guarantee information symmetry, so that everyone sending in their transactions has the same chance, and no matter how close they are, for example, to a validator. Yeah. So that to your first question of how do these types of mempools compare, and then your second question was what's the problem that we're actually solving, right? So yeah, maybe then let's take one little step back. Is kind of right. What's MEV? What's front running? It is the practice of extracting value. So maximal extractable value is the value that anyone can extract from transactions by reordering or front running or censoring transactions. So anything where you can meddle with the transaction order, that's where MEV kind of emerges, and extracting that leads to MEV, I would say. And then the simplest example is front running, right? Where you see, the classic example is you see a big buy order coming in before other people see it, and you can place an order right in between. So you see the big order coming in, which will definitely move the price up. So you can jump in and you can buy cheaply still from the public market, basically, drive the price up, and then sell to the guy who has already committed to this big order, and that leads to this loss for the guy who sent in his order. And the unfair part is, so it's not unfair in terms of, if you see the opportunity and if you're quick, then you should have that opportunity, right? And arbitrage should exist, right? But the problematic thing is where the capability and who sees this information first is sort of asymmetric, and is let's say either someone who operates the infrastructure themselves, or someone who is extremely sophisticated and has special tools and knowledge about the transaction supply chain. So kind of the asymmetric and centralized nature of who can exploit these opportunities, that's the problem. More so, I would say, than the front running itself. So the front running itself, you can kind of a lot of front running already doesn't exist anymore, because you were just trusting some intermediary not to front run. You're just saying, okay, please don't front run me. Boom, then that problem is kind of solved, right? But then this entity that you're trusting not to front run you then still has the ultimate order, the power to order transaction and to extract value from it. So this is a centralizing tendency, because that entity becomes even more powerful the more they can extract, and the more kind of they control the transaction ordering. So I'd say like that asymmetry in terms of who can order transactions and who can exploit the knowledge, that's, let's say, the problem, and that leads to the longer term inefficiencies and bad prices for users and bad experience for users. and also censorship, right? So because the same capability of ordering transactions also allows you to censor transactions, and I would say censorship resistance is the whole reason for existence for public blockchains. So if you can then censor again, then that's a big problem as well. And we're seeing a lot of censorship in the PBS supply chain. So we're seeing we're seeing builders, relays, proposers, right, and RPCs. So if you take that entire supply chain, each of these kind of supply chain intermediaries can censor, and a lot of them do. So can I only recommend this dashboard by Tony Warstetter, he outlines which percentage is censoring and who aren't.
How does this censorship by reordering happen? It's like you put a transaction that would invalidate the following one when you reorder.
You look at the content of the transaction, and you are able to not include it, right? So the absolutely classic example is the OFAC list, right? So Tornado Cash and some other instances. You now have Ethereum addresses on the OFAC list, which are sort of sanctioned addresses, right? So then you have large supply chain intermediaries, let's say a relay, which has a presence in the US, let's say, and they need to comply with sanctions regulations. So they include the OFAC list into their transaction ordering, their block building sort of mechanism, right? And they only accept transactions which adhere to which do not come or do not touch OFAC list sanctioned addresses. And then if you are on one of these addresses, if you use from Tornado Cash in the past or something, then you might not get your transaction in, right? Or not in quickly, I would say, right? And it's not a real problem today, right? Because there's very few addresses on the OFAC list, and also you will get your transaction in eventually, because there's still a lot of validators who are not censoring. So it's not an extremely immediate problem today, but the more we go in this direction where we kind of are trying to control and censor transactions, and we have a certain percentage of the transaction supply chain be censoring, I think the threat is there. The threat is extremely fundamental, because again, I think that's the whole reason for blockchains to exist, that they are kind of a permissionless public ledger where it doesn't matter who you are and whether maybe you used Tornado Cash in the past or not. You should be able to transact, right? And stuff like my personal opinion is stuff like crime enforcement, or stuff like money laundering shouldn't happen on the protocol level. It could happen on the level above, or it could happen at the entry and exit points of the system. But sort of like embedding these kind of pretty deeply reaching things into the chain, I think isn't really in the spirit of cypherpunk and blockchain, right?
Oh man, I'd love to take this snapshot here of the podcast and do a short video with you explaining it. It's so good.
So, of course, kind of like encrypted mempools and things like, let's say, shardized voting and snapshot and so on. It's very kind of particular technology because it enables more of that kind of like more the equal opportunity for people. Is it something you feel kind of like is also in the, let's say, in the more of the DNA of, for example, BrainBot and Shuttle Network itself? Like, where does it come from? Because it's like it's really cyberpunk, isn't it?
I hope to think so. Yeah, exactly. Yeah. So I think there's definitely like a resurgence of that, right? So maybe last couple of years was like, let's say, some NFT stuff, or some of these things were kind of not sort of some of the newer people in the space, they don't really connect that much to the original ideas of, hey, let's build kind of a censorship resistant, credibly neutral platform. So I think it's good that we're now seeing a little bit of that resurgence, and people also like I really like these efforts, the DarkFi stuff, Amiataki, and in general cryptography, I think, so threshold encryption or fully homomorphic encryption, MPC, I think that's hopefully all in the spirit of the cypherpunk spirit of giving users more control, ensuring privacy, ensuring kind of information symmetry. Yeah.
Yeah, that's the role. That makes sense. How do you see this solution helping in the aspect of modularity that's being so discussed right now in the ecosystem as a whole?
Yeah, it. I mean, there might be a case to be made for it to add directly to modularity, but I would say something different. I would say rather the encrypted mempool is a module that rollups can utilize and plug in, right? So in that sense, I like it. I hope it contributes to the thesis of modularity, where, yeah, I mean, I love this Lego thesis, right, of building your own rollup and choosing the DA layer that you think is right for your chain, and choosing an execution or consensus mechanism that makes sense for you, choosing maybe, I don't know, proper transaction ordering policies, things like this. And in that, I think it's another module to differentiate your rollup as well. So if you have I think we're seeing like a lot of rollups that are very, very similar to each other, and I think I would say longer term there's definitely a threat for consolidation if the rollups just look really too similar, all of them. So in that sense, I think what's really needed is really protocol level differentiation. I think Cartesi is a prime example where it's really different, right? And it enables something that, for sure, something like the existing optimistic or ZK rollups don't offer at all, right? By having this more generalized VM. So I think in that spirit, I think it helps with modularity because it provides a protocol level differentiator and provides a meaningfully different kind of transaction experience and transaction ordering capability.
So since one of your use cases, for example, let's say shutterized voting, so Cartesi is all about, let's say, application-specific rollups and so on. Like it's much closer to kind of like the more core business that, let's say, a rollup an application is trying to do. A little bit like, for example, now Uniswap has the unit chain. Do you see, let's say, your offering Shuttle Network being closer to what, let's say, your customers being the applications directly instead of, let's say, more general purpose networks in this particular case?
Awesome question. Yeah, I think definitely both. Both, and that's exactly the two different examples we already have, right? So we have with Gnosis Chain, we have a very generalized purpose network as one integration. With Snapshot, we have an extremely application focused. It's even off chain, right? The Snapshot integration is fully off chain, so there's not even there's no chain involved even, right? So or there's some level of chain involved, but like not really for the encryption decryption. So I would hope it can be used for both, and I think application specific rollups would be very interesting as well as an integration. So it could be like think about kind of snapshot. Let's say a snapshot as a rollup thing could work well. I would say like shielded voting as an application rollup. Something I would say like just building a DEX specific rollup that has encrypted trades right kind of embedded into the application specific rollup, or differently put a blind auction mechanism. So that's something that others have also proposed as a very application-specific application of threshold encryption, to have threshold encrypted blind auctions, and people submit their bids, and then they only get revealed after everyone has submitted their bids, right? Yeah.
Mm-hmm.
So I think those are all possible and great use cases of threshold encryption.
But I think also now that we have, for example, been talking to Espresso in a previous episode of this, and we're getting to a point where, let's say, we can almost have, let's say, gigabytes per second data dispersal of things, right? And it's like technology like yours can also be used to really put in, let's say, censorship resistance, right? Because let's say if somebody wants to, let's say, make a small radio channel or something like that, like the blocks that are being built can't really be censored, right? We don't know what's in them until they are revealed eventually, for example, or forums and those kind of things. This kind of like this kind of like promises a little bit we had in Web3 way back, but we never kind of got around to actually doing. Like, why don't we have Web3 Reddit that people actually use, for example?
Yeah, no, fully agree. Yeah, I think that's a great way to think about it. Yeah, and yeah. I mean, I think in a way, sort of blockchains solved transaction ordering for longer time scales. So for like on the minutes and for Bitcoin, let's say on the 10-minute scale, right? And for Ethereum, maybe on the 10-second scale. But they didn't really solve it below a certain time threshold. So I think that's where encrypted mempools come in, because they can hopefully solve it for the more high frequency trading or everything below, let's say, this 10-second span. Yeah, and then and having censorship. So we have eventual censorship resistance, right? In Ethereum, again, even if 90% of all validators would censor, after a couple of minutes, you would still get your transaction in, even if you have only 10% non-censoring validators. So I think we're on sort of eventual censorship resistance and longer term censorship resistance, but we're not really doing well on kind of short term and real time censorship resistance. Actually, even something that Vitalik in the blog post from 2017 or something, 16, touched on when he talked about censorship resistance. He talked about, well, there's the general censorship resistance, but the real-time censorship resistance is very important too. And he gives this example of derivatives trading, and kind of where time really matters, right? If you have let's say an option that only executes at a certain strike price, something like this, or some product that only executes at a certain price, and it only hits that price for a couple of seconds, then you can easily be censored in that time, and you're then missing out, and you're not getting your payoff or what you wanted to achieve there, because you're getting kind of real time censored, and in that case, kind of the longer term censorship resistance doesn't help you, and you need the more shorter term. Yeah.
I see. We do have an example of an application. It's just coming to my mind right now. Carsten, do you think this could have any kind of relation with what DCA Monster does, which is the continuous trading like stream?
Yeah, I mean, I think so for sure. Like anything that comes down to trading and like ordering it and like moving things into a rollup for sure makes sense to look at, let's say, preventing, let's say, abuse in terms of AV and so on. So possibly as well.
I see.
But I think also potentially even something like games and so on could potentially, let's say, benefit for something like this as well.
Yeah, this was actually something that was talked a lot, games, in the blog post that you wrote for talking about Cartesi with Shutter, right? How that would work. Could you give us some insight on what's in the post? How was the experience of writing that? Motivation behind it?
Yeah, I can give maybe both. Maybe first on the games, and then yeah, on the yeah. So I think the games aspect is very interesting for threshold encryption, or commit reveal mechanisms in general. So the simplest example is, and we just built that again for NanoShatter, for the hackathon version of Shatter, is rock paper scissors, right? So when you play rock paper scissors, you can really easily show how important information symmetry is, kind of. So if you or commit reveal is, so if you play it with a delay and you say kind of one person reveals their move later than the other person, right? So let's say we play it, and then one guy does the rock, and then the other person sees what they're doing, and they can do paper to react on top of it, right? So that's a prime example of where you definitely need a commit review mechanism, and where I think a decentralized commit review mechanism like Shutter can make a lot of sense. I think similarly in some of the strategy games, so my colleague built this game called Diplomacy, which is a diplomacy version that uses for DAOs who play against each other and need to kind of capture territories. And there again, the same problem exists where you are moving all in one kind of move. And if one DAO can see what the other DAO is doing, then the game breaks. And there it makes sense to kind of encrypt and only reveal the move afterwards. Yeah. So that for games, and I think there's many more cases like this where you have these sort of commit reveal kind of problems in games. Yeah. And then for the blog post with Cartesi, I think the focus there really was on what is MEV in generalized compute, right? So I think it's easy to see what MEV is in finance or in DeFi, but because Cartesi allows these more generalized all kinds of applications, I think that was really interesting to see what type of MEV exists in generalized computing, right? And then it was about the games as one example, or I think we touched on kind of resource allocation potential, where maybe if somebody wants to access certain resources and you have a queue there inside of computing essentially, and if that runs in a decentralized way, you might run into similar MEV type of issues like you do in finance, but on the computing layer. So yeah, I think also another interesting sort of topic to think about is sort of MEV in with autonomous agents, right? So I think someone else said this, but I'm just trying to. So if let's say you have a super autonomous agent, which is very sought after and who has capabilities the others don't, and people are again they're kind of trying to pay it and to receive services from that super agent. And there you have again like a queue system, and you have congestion, and you'll have potential kind of front running to access that micro service or something from this super autonomous agent. And in general, autonomous agents are bots, right? Kind of like MEV bots. So if you fill the chain with these kind of LLM powered MEV bots, I think that'll be quite interesting for MEV as well. And I think that'll be very crazy. The kind of this vision. Yeah, I'm very excited about autonomous agents on.
Yeah, definitely. This is something that I keep thinking. Like, what are the specific techniques you use to do this whole process of threshold encryption, right? What are the things that get there in the nitty gritty? What are we talk about many trust assumption models, right? TE, FAG, MPC. How these technologies work when you think about Shutter Network? What is applied in there? Exactly how it works? Do you have an insight on that?
Kind of just comparing the different primitives, right? Yeah. So threshold encryption differs from also I think what's used currently really as the closest competitor in a way for transaction ordering is TEEs, right? Which is a trusted execution environment where you have specific hardware, for example, Intel SGX or AMD SEV, that is built in such a way that you can do computations inside of that kind of enclave without revealing what's happening. So that's why it's kind of a natural fit for the same use case, and it's tempting to use it, right? Because it's simple, because you can usually just run the same already existing code inside the hardware enclave that you already have. And you can do, crucially, you can do operations on top of encrypted data, or not encrypted data, but you can do you can hide the full computation, right? So comparing threshold encryption to that, Shutter uses threshold encryption, right? Comparing threshold encryption, it is different in that it doesn't allow you to do that. It doesn't hide the computation. It only encrypts and then decrypts and then executes afterwards. So the computation is in the open, right? That's one downside of threshold encryption. But we don't think you need it for this use case, for the front-running prevention, because you can commit beforehand to the auto transaction, then you can execute them afterwards. Yeah. And the other aspect is, with this kind of trusted enclave, trusted execution, that you are trusting this hardware trust assumption that, let's say, Intel or AMD hopefully hasn't built in a backdoor, or hopefully is fully secure. Right? We've seen a lot of Intel SGX vulnerabilities and hacks. So this hardware trust assumption is something that I would say is a downside of TEEs compared to threshold encryption. Threshold encryption is trusting the cryptography and trusting the level of decentralization of the keeper set. Right? You mentioned the threshold trust assumption. So yeah, we do have a trust assumption there as well, which is that X amount of what we call the keepers who are running the threshold encryption knows that they don't collude. So if a certain number of them do collude, so it can't, the protocol can't tolerate a large number of keepers colluding and nothing happens. But for a certain threshold of them collude, if enough of them collude, then we have that issue that they could then again decrypt early and then be able to front run again. So I think that's the difference between threshold encryption and TEEs. I think TEEs are great kind of for certain use cases, but I think it's not really that suited for really kind of the decentralized and the censorship resistant base layer of blockchains, right? Yeah. And then it's super interesting to talk about MPC and FHE, but maybe this would be a little be about kind of too much for the time here. But essentially, FHE I think is super interesting. Fully homomorphic encryption means you can kind of combine. You probably need to combine there with some kind of threshold, because in FHE you also need key generation. So if you combine FHE with a threshold key generation mechanism, say a threshold FHE, then you have sort of this holy grail of you can then hopefully run the entire block building process and transaction, even maybe transaction processing, inside of this cryptographic black box, and it is verifiable, and it produces kind of valid transactions without anyone seeing what's in there, and then you can have all the properties you need, right? The information symmetry, privacy, front-running existence, everything. So I think that's super exciting and something we're looking into, and hopefully kind of at some point adding on top of kind of moving from just threshold encryption to threshold FHE from the shared perspective. But as of today, it's probably not really scalable there. So it takes sort of like 1 billion times or more amount of computations to get to the same.
Throughput is still not there yet.
Yeah. I mean, it depends on the use case a little bit. Maybe there's certain simple use cases that do work with it, and Zama are doing some amazing stuff. But yeah, in general, the consensus is that for these transaction processing use cases where you kind of need quite a high throughput, that is not really viable today. Yeah?
So if I'm a developer and I want to start, playing around with Shadow Network, because I think of an amazing use case that this can help for my Cartesi application today, for example, what is kind of like the best way to kind of like start trying out Shutter, or even in production? Like, do I have to pay something to use the network, or how does it work?
The best way to try it out, if you just want to kind of let's say a developer on Cartesi, or developing games, for example, for Cartesi, I think the best way to just the very first step, I would say, is what we just released, the Nano Shutter, which is kind of really a playful way of, and it's really not really safe for production use, right? It's just an API that just generates keys. I think that's a cool way to just prototype and just kind of get familiar with this concept of what I said before, right? Encryption, commit, decryption, execute, kind of that. Yeah. So I think that I would point people to that. And that is fully open source, and we run the API, so you don't have to set up yourself. You can just use the API that you just run it against the API that we provide there. And then your second question about payment. So today there's no payment, no fees for it. So it's all free and all kind of provided as a public good for now. But yeah, hopefully at some point we think it is a valuable service. We think kind of similar to, let's say, a Chainlink Oracle service, right? Which is also like not an extremely expensive service to produce, right? It's just data essentially. But we're thinking at some point people will realize that it provides a lot of value in terms of, again, sort of saving you in terms of not being front run, or ensuring information symmetry, or making votes making the voting process more fair, and having more information symmetry. So then we would at some point the keepers will probably charge a fee, right, for that service of encryption decryption.
Got it. Luis, I think this would be a nice time for us to move to the rapid fire round. Do you know what's that? We're gonna do a quick ping pong where I'm gonna ask you a bunch of questions and you have to answer them real fast, barely thinking, with like one word or one small sentence.
Okay.
All right.
I'm a little bit. My brain is a little bit muddy, but let's see.
I think you're gonna nail it. Pretty simple questions. So first one is probably the hardest one. Choose one word to describe Shutter.
I wanted to say baseline neutrality, but then let's just use neutrality.
Neutrality, all right. One Web3 protocol you, Luis, personally are inspired from.
OLAS. I love OLAS, autonomous agent stuff, and I love how they have practical autonomous agent use cases, and they have a very simple way for normal people to run the agent as well, kind of like harking back to the good old Bitcoin days where you just start your desktop application. So it's called Perl. So that I really appreciate that anyone can just run it and stake some OLAS and run the agent.
Okay. Now this is a hard one. What's your favorite drink?
Americano. Not the coffee, but the drink, right? Yeah.
It's impressive how many people end up picking some variant of coffee.
No, it's not coffee.
Oh, it's not coffee?
I mean the cocktail Americano.
Oh, the cocktail Americano. All right.
Smooth, Campari. Forgot the other stuff. And then you can also have Americano Perfetto with beer.
That's good. That sounds weirdly good. I like strange combinations. Now, in one sentence, what's the biggest challenge of Web3 right now?
I think this conundrum between staying true to kind of ensuring that it is reasonably differentiated and is base layer neutral and is differentiated from a centralized exchange, while at the same time providing exceptional user experience and latency and throughput.
Great. Now, from every crypto event you went to, what was your favorite one?
DevCon 3 in Cancun.
DevCon 3. Now, give a shout out to one person that has inspired you.
But only because this was my first DevCon, so people tell me that DevCon 3 was pretty shit and pretty commercial, and the ones before were the best ones, like Shanghai. So what was the last question?
Yeah, shout out to one person that has inspired you.
I think what most relates to what we're doing and we're currently working on, and hopefully what we're revealing soon. Martin Kuppelmann from Gnosis, who's always been kind of the strongest base layer neutrality advocate, and is one of the few people who are still really fighting for it relentlessly.
All right.
Thanks. Those are great. Those are cool questions.
Yeah, those were the ones I had for rapid fire specifically. But yeah, we were talking about games just before, and we do have a solution called Rives.io, which is the old World Arcade where people can play Doom, where people can play mostly single player games, right? So it's more about playing single player games and being the best in the leaderboard, having your gameplay verified online with the whole log, with the whole history. How do you see Shudder enhancing this solution specifically, as it's not a multiplayer game? Do you see any use case where it can?
Interesting. I have to look into it more closely. So how does it work, the game?
So you basically go on, Carsten.
Yeah, so basically the way that Virus is working is it's a fantasy console, right? It has different cartridges you can kind of put in. But typically the way it has been so far is kind of like there's a leaderboard, for example. So basically you're submitting, let's say, gameplays and they get verified on chain one way or the other. So basically what has been so far, we had Doom Olympics. So obviously people are kind of like competing towards kind of like getting the biggest high score and so on. And I mean, from my point of view, like with Shudder could for sure help, maybe let's say keeping the gameplay secret until let's say the end of the Olympics. So you're not completely clear where you're actually standing with the high score, for example.
Yeah, I mean, yeah, I think it would have to be, I think, on a very granular level, because again, the issue as with threshold encryption in general is that you can't compute on top of encrypted information. So at least not how we have built it today, right? So if everything that is encrypted wouldn't then be able to be processed. So I'm thinking more so I think it would have to be on the game, or just maybe not, but maybe it would have to be on a per game basis. And let's say there is something that I mean, single player is hard, I would say. I think it's more really useful for multiplayer. But let's say, I mean, you can also consider a single player. You can also consider that a multiplayer game, in that you have a single player playing against the machine, right? I think that then it's like a multiplayer game, yeah. So I think I would think about in the game where is information that either the player or the machine could where the player or the machine could leverage some information advantage or information asymmetry against each other, and then it would be cool to have that be encrypted or committed and revealed to, like, I don't know. I mean, it would be cool to have like something super like real time, where let's say the player position, right, is where the player position would always be hidden until, I don't know. I'm just thinking about like Counter-Strike and but again, it's a multiplayer game. But they're kind of this. That's a classic kind of rock paper scissors thing, right, where somebody is behind a wall, and if they already know where the player is going in the next step, then they have an information advantage and stuff like this. But it's, I think it would be on. I think another way to think about it is kind of card games or real-time strategy games, or strategy games in general, might be a better fit. Yeah, but yeah, I think we'll have to do some brainstorm and some thinking around it. I have a look at the games. It's awesome to see the games. Yeah, we have to look at all the games.
I mean, something you can do is like record a tape of your game, and then people can see the tape of this game to prove your gameplay in some way. I think just through that, some degree of threshold encryption could probably help. So you commit the gameplay, and then you reveal in some way as to not necessarily instantly show everyone what's happening. And how you beat the game, so people cannot take your strategy to use it or something. I think that would help immensely.
Yeah, or maybe in terms of if there's voting, right? So if there is well, maybe not. Usually those are those are very objective. That's the whole point, right? You have objective scoring system. But if there was a voting of who had the best game, or who did the best, who played the best, like in terms of that's more subjective, then I'd say the voting process would be cool to have encrypted them.
This is actually an insanely good possibility, because you take the pragmatic view on top of the game, and you start to see the subjective way of playing it. Like, there are different strategies on which you say who applied the strategy better, even though they didn't have necessarily had the high score or the fastest gameplay or playthrough. Yeah, this is cool. One last more technical question I think we haven't talked about this yet, is on private RPCs. Did we talk about it yet? No, right? So how does Shutter Network approach the reduction of trust assumptions, and how does this compare to traditional private RPCs?
Very good question. Yeah. So I alluded to this earlier when I said kind of when I try to explain the different mempool types. And yeah, private RPCs, I would say they have that private RPC versus encrypted RPC. The downside of the private RPC is that you still have the trust assumption of the RPC provider who sees all your transactions, right? And they can theoretically front run you. And if you then put that in the PBS supply chain, so can still the other, for example, builders can do that. And that's actually what just happened to MEV blocker, is that there was a transaction that went through they have two paths, and the fully private, the supposedly fully private transaction path, what was still front run by one of the builders, because they send the transactions to quite a lot of builders, and because it's not encrypted, or because there's no strong enough commitment in this process, the builders can, if it's profitable enough, they can just cheat and just say, well, I'm going to tell someone else about this opportunity, and I'm going to front run. And I think it was like a 250 ETH front run, which happened, yeah. And that exposes that trust assumption and that issue with private RPCs. And I think it's on the one side, it's that kind of a fundamental difference between a public encrypted mempool and a private mempool. And on the other side is maybe something that we can even help them. So we're good friends with the MEV blocker team and the CowSwap team, right? And we have proposed to them to kind of use threshold encryption in that, or the Shutter system, to have it plugged into that system, and to protect the users from MEV blocker by having MEV blocker then commit to the included transactions, and so kind of like protecting them via this encryption mechanism. Yeah.
This is awesome. So, Luis, I think we have one final question coming from the community, and it comes from Felipe, and he asks, how do you deal with the argument of plausible deniability in the context of transaction censorship on private mempool? Then he sent on parentheses, sequencer censoring and not being attributable to it.
That is an interesting question. So I'm not sure I fully understand the question. So or there's two different ways I would interpret this. Or let me give both answers, and maybe hopefully one of the two answers was the one that. So the one aspect where we're talking about plausible deniability in the context of transaction censorship is this case. Let's say what we talked before, the OFAC case, and you have a pressure on the transaction supply chain intermediary, or in this case a sequencer, to censor, because like a regulatory pressure, right? Because they want you to censor. So in this case, we're arguing that having the transaction be encrypted and thus we're kind of taking away the ability from the sequencer to censor it, and we think that that initially sounds like a downside for the sequencer, right? Because then they're restricted in what they can censor or not. But we also think it's actually could be a good thing for them in terms of the regulatory pressure, because then they can argue, well, we weren't even able to censor because that's because it's encrypted, right? Like WhatsApp can, I would say, plausibly argue that they shouldn't be responsible for all the criminal activity that goes on with people who send each other WhatsApps, right? So I think that could be a strong argument for a sequencer to implement an encrypted mempool to protect themselves and to have more plausible deniability. Yeah. And the other direction that this could go into, but I'm not sure if that was the intent, was kind of about attributable fault attributability. So yeah, in threshold encryption, you don't really know who, if somebody colludes, you don't really know who colludes. So that's a fundamental, interesting cryptographic problem that we're working on, and there's some interesting cryptography or crypto economics, hopefully, that we can solve this by essentially having a snitching system where you can snitch on others. The keepers can snitch on other keepers and kind of prove that they colluded, and then snitch on them, and then hopefully you can solve these kind of attributability problems. Yeah.
Yeah, makes sense. I think it was the first one. I think it's sequencers in your system could be equipped with the argument of plausible deniability in the context of transaction censorship, right? So I think that was the correct elaboration. Anyway, I think that's it. We got some good questions, some good talk, and yeah. Louis, if you want to say some last words, I would love to know, especially in terms of adoptions and use cases, what you see ahead for Shutter Network. And if you want to say anything else, here's the opportunity as we wrap up the podcast.
Awesome, yeah. No, thank you so much for having me. Super interesting discussion, many different awesome topics. I love Cartesi. I think it's really like powerful to have more generalized computing capabilities and calculate, and so that's awesome. And yeah, it would be awesome to as you say, like find use cases where it overlaps Shutter and Cartesi. And the gaming, I think the gaming stuff is probably the best avenue. We should maybe brainstorm on what's the subset of games where both technologies would make a lot of sense. I think we have some efforts there going on, I think, to hopefully kind of build games or have the ecosystem, incentivize the ecosystem to build games. Yeah, so I think that's a super interesting discussion. Yeah, and in general, what I said before, like kind of recommend everyone to kind of think about blockchain as a censorship resistance mechanism, and who is censoring and who's not censoring, and how can we have more basic neutrality. Ultimately, that's, I think, the value proposition of blockchain, and that's what differentiates it from a centralized exchange, right? And why do we need even Ethereum compared to just use, I don't know, some centralized exchange? Yeah.
Food for thought. That's great. So we can end up in this reflection. Carsten, if you have any last words as well, stage is yours.
Thank you very much for coming. It's been really interesting, and I plan also to dig into shadow APIs myself a little bit more now as well.
Thank you so much.
Bye, everyone. Thank you so much. Keep building and pioneering the world of Web3.
You too.